Halogenation is a chemical reaction that involves the replacement of a halogen atom with another substance. Water disinfection is the removal, deactivation, or killing of pathogenic microorganisms. Halogen is used in water disinfection because of the efficacy against waterborne pathogens, bacteria, virus, protozoa, and fomites, the ability to produce a residual that provides an added measure of protection against possible post-treatment contamination. Type of halogen that can be used to disinfect water are first, chlorine. It is more cost-effective, reliable, and effective against a wide spectrum of pathogenic organisms, effective in oxidizing in certain organic and inorganic compounds, and can eliminate certain nauseous odor. Second, iodine. In low concentration, it's effective for killing bacteria, virus, and cysts. In higher concentration, iodine is effective against fungi and bacterial spores.
Now, halogenation reaction mechanism. During halogenation, depending on the halogen, an alkane will undergo fluorination, chlorination, bromination, or iodination. Here are the steps that occur during the chlorination of methane. Firstly, initiation. During the initiation phase, ultraviolet light splits the halogen into two radicals, which is atoms with a single unpaired electron. Second is propagation. During propagation, the halogen is made to react with an alkane. The hydrogen atom is delinked from the carbon, resulting in formation of methyl radical. Third step is termination. Termination occurs when the chlorine atom interacts with another chlorine atom to produce Cl2, or when the chlorine atom reacts with a methyl radical to produce chloromethane. Halogenation reaction kills microorganisms by disrupting the cell membrane. This reaction involves halogen atoms reacting with fatty acids in the membrane, making it leaky. The cell membrane is crucial for protecting the cell and facilitating nutrient transport. Halogenation reaction replaces hydrogen atoms with halogen atoms in fatty acids, increasing membrane permeability. Leaky membrane allows contents of the cell to leak out, leading to the cell death. Halogenation reaction can form hydroxides, free radicals, and denatured proteins, damaging other cell components. These lipids in the membrane can be damaged, further increasing permeability. Halogenation is effective but toxic, requiring safe and controlled use. Precautions should be taken to avoid human and environmental exposure to halogen atoms.
Next, benefits and drawbacks of halogenation. Chlorine, iodine, and bromine are the most common halogens used for water disinfection, but the best halogens among them is chlorine. Here are the reasons why. Benefits of halogenation, especially in chlorine. It is effective against a wide range of microorganisms. It is also easy to use. Chlorine can be added to water in variety of forms. It is also low cost. The cost of chlorine, the most common halogen used for water disinfection, is relatively low. This is because the wide availability of chlorine. Chlorine is a widely available chemical and can be easily transported and stored. But there is also a drawbacks of halogenations, such production of harmful byproducts. When halogen react with organic matter in water, they can produce disinfection byproducts, in short term DBPs. The most common DBPs are trihalomethanes and haloacetic acids. It is important to note that no method of water disinfection is completely free of risk. However, halogenation is a safe and effective way to disinfect water, and water utilities take steps to reduce the formation of disinfection byproducts. The examples in our daily life of benefits and drawbacks of halogenation. First, the residual chlorine in the water helps to maintain the safety of treated water. However, the residual chlorine in water may break down if the water is not used and possibly forms disinfectant byproducts. This is one of the reasons you should let a faucet that has not been used for like days or weeks to run a little bit before drinking it. While tap water is safe to drink, but it is important to note that the quality of tap water varies depending on where you live.
Let's move to safety of halogenation. Halogenation is a chemical reaction in which one or more halogen atoms are incorporated into a molecule. The risk of exposure to chlorine and other halogens include skin and eye irritation, weakness, central nervous system effects. The last one, respiratory problems. To minimize the risk of exposure to chlorine and other halogens, it is important to take the following safety precautions. First, wear protective clothing. Next, work in a well-ventilated area. Last one, follow proper procedure. Here are some additional safety tips for halogenation. First, use the lowest possible concentrations of halogens. Next, avoid contact with skin, eyes, and clothing. And wash hands thoroughly after handling halogens, and so on.
Are you guys still okay? Hopefully yes. Now we move to future of halogenation. Let's discuss about future, the new halogenation technologies and the use of alternative methods. Firstly, we have to know why search for other alternatives. This is because of related concerns about DBPs formed during halogenation. Next, what is DBP? DBPs are chemicals that are created during the disinfection process to react with disinfectants like chlorine. These are examples of halogenation. First one, balance between effective disinfection. Secondly, enhanced DBP reduction. Then, combination approaches. Last but not least, focus on sustainability. Is this the end? No, not yet. So, the alternative method is by using advanced halogenation technology, chlorine dioxide and chloramine for ClO2. It is effective against a variety of bacteria and demonstrates significant disinfectant properties. For chloramines, they are formed by combining chlorine with ammonia. Compared to free chlorine, they disinfect at a lower rate but provide better DBP management. In order to maximize currently used disinfection techniques, raise energy efficiency, lower prices, and understand more fully the long-term implications of alternative disinfection technologies, further research and development is required. Congratulations! You have arrived at the end of the topic.